Here are some basic moment of inertias that you should know for all problems, along with some others that will be very useful in order to solve questions. Now let's do an example. An object consists of two particles, mass m1 and m2, which are connected by a light rigid rod of length L. Neglecting the mass of the rod, find the rotational inertia I of this system for rotations of this object about an axis, perpendicular to the rod and at a distance x from m1. Part B, show that I is a minimum when x is at x center of mass. So for part A, in this case, it is asking us, neglecting the mass of the object, find the rotational inertia. So first things first, we're going to draw these two masses, m1 and m2. Okay, and it's saying that its axis of rotation is about here, where this is the distance x, and the total distance is L. So this means this is L minus x, right? Okay, and it's asking us to find the rotational inertia. So we're going to go back to our rotational inertia, to our definition of moment of inertia, which is I equals integration L d squared dm. Okay? Now in this case, we can replace this by a sum r squared dm, or r squared mn. Okay? So since there are multiple r's and multiple m's, we are going to reduce this down to this expression right here. In this case, n, it goes from 1 to 2. Okay, so this moment of inertia can also be written as r1 squared m1 plus r1 squared m2. Okay, and then r1 is going to be just simply x, and r2 is just simply going to be L minus x. So in this case, I can rewrite m1 r1, which is x squared, plus m2 L minus x squared. If you would like to solve it, you could solve it further, but I think this would be more than enough. Okay? Part B, it says that rotational inertia is a minimum when x equals x center of mass. So from the basic calculus, we know that in order to make this into a minimum, for a minimum condition, we do di over dx and we put it equals to 0, okay, for the condition of minimum. So this is going to be di over dx. That will give me m1, 2x, plus m2, whoops, I have it as squared here, plus 2ml minus x times minus 1, right? So I'm pretty much, all I did was take a differential with respect to x of this expression right here, and that's what I get. So this implies this is going to be 2m1x plus 2m2 L minus x. And there's a minus here, so I'm going to replace this as 0, and the condition of minima is that this has to equal 0. This implies that this is going to be 2m1x equals 2m2L minus x. Right? So the 2's will go away, and I can collect all my x's on one side, so it'll be m1x plus m2x will give me m2L, right? And if I was to rearrange the stuff, I could write x m1 plus m2 gives me m2L, which means x will be given by m2 over m1 plus m2L. Okay, look at it carefully. What is this expression? This is a center of mass of an object. So this implies that is absolutely true, that this has to be at its x center of mass in order for this minimum condition to hold true. And we've just proved that.